Equilibrium of three vectors with one unknown. Here's what we'll do. We'll start off by creating our vector system. We're going to come out of a common point and we're going to say that, well, we can have as a situation, I'm going to say it's a tug of war. I'm pulling down at 10,000 newtons. I'm going to call that F1. You can be pulling off F2 at 6,000 newtons, and we'll have that going at 25 degrees. And your friend, who we don't know, they're going to have some unknown force, F3, and they're going to be pulling off at some unknown angle. Okay, there's our original free body diagram, what's going on. What we need to do is we're going to need to identify our x's, that x and this x, and we also need to identify our y's, this y, that y, and this y. We're going to first of all start off with the x's. Actually, before I do that, I'm going to label everything. This will be F2y, F2x, this will be F3y, and F3x. And this has no x, it's just a y. So, let's say, alright, sum of fx's. That means that I'm going to go f2x plus f3x, and they should equal 0. But we know that this is negative, so you know what, I'm just going to throw it as a negative. Now I can go to my f2x, look at what it is. Well, it's going to be 6,000 cosine of 25 minus f3x equals 0. So f3x equals 6,000 cosine of 25. I'll figure that out. And it ends up equaling 5,437.8 newtons. And it's left. So we'll call it a negative. There we go. I'll do my sum of fy's next. That's going to be f2y plus f3y plus negative 10,000. That equals 0. My f2y I know is 6,000 sine 25 plus f3y minus 10,000 equals 0. So let's just solve that for f3y. That is 10,000 subtract 6,000 sine 25. f3y ends up equaling 7,464.3 newtons in the positive direction. There we go. Those are our two components. That is our third y vector there, f3y, f3x. So what I have is my x and y components, so let's figure that out. If I draw a quick little component diagram here, the total x's was this way, and my total y's are that way. And this is that resultant vector that our friend needed to be, this f3 person. So this was that's my x's, so that's 5,437.8 negative, and this is 7,464.3 positive, and we have to find that angle. So the first thing we'll do is we'll find our resultant. That's going to be a squared plus b squared equals c squared, so that's going to be 5,437.8 squared plus 7,464.3 squared. F3 ends up being equal to 9,235 newtons, and we want to figure out what degree that's at. So you go tangent of theta, because that's opposite and adjacent, and that's what it's going to be, 7,464.3 5437.8. Solving that all out, you get 54 degrees. So it's going to be at 54 degrees, and then we figure out that it's north of west. That is the vector that we would need to have here to balance this whole situation out. 9,235 newtons, and this is going to be 54 degrees. So there you go, that's how you could do it. You could also find this angle by taking either your fx or your fy. If you remember, fx is f cosine of theta. So you could go take your fx, so you could go 5437.8, set it equal to your new f that you found, 9235 cosine of theta. Solve all that out. You'll get 54 degrees still. There you go. Equilibrium of vectors with one unknown.